So I'm from the University of Birmingham, and I'm involved in providing the HPC facilities here. At the University of Birmingham, we like a good acronym. So the HPC facilities and other things we're provided are called the Birmingham Environment for Academic Research. Obviously, that allows us to use the word bear lots, and when you see lots of our publicity and other information, you'll see pictures of bears. On there in that photo are just a couple of the bears that one of my colleagues has sitting around in their office. On the other side, that's our water-cooled data center, which opened a couple of years ago now, or nearly 3 years ago. That's from quite early on, actually, when we had a bit of it. You can see some of the compute nodes, some of the storage, a small amount of the Power 9 AI cluster that IBM Power 9 AI cluster that we've got in. That's before all of it was there. Our group's also responsible for research, what we call the research data store, which is providing storage across campus. So that's both for people using HPC facilities, but an awful lot of our researchers that use it don't use HPC at all. We've also got high-speed networking set up. That's for people who say, either say in the medical research area doing gene sequencing. We've also got some of the physics type equipment that's producing lots of data and chucking it back into the store. We've also got a GitLab set up internally for researchers who want to keep their Git repositories local. Our computer, our HPC machine, continuing the theme of Bear, is called Blue Bear. This is available to any researcher at the university. I have lots of bioinformaticians, a good chunk of engineers, computational chemists, physicists. But a lot of what goes on our system is high throughput computing rather than high performance computing. We do have a chunk of high performance computing type users, but we often see lots and lots of jobs and lots of package requests from those bioinformaticians. Our system, we have the section of it that's available for free to all researchers, but also research groups can come to us and ask to buy additional resources. That's either, you know, the groups that use lots of computational resources might want to have their own dedicated nodes as resources to them, or they might have some extra requirements to do with particular dedicated access to GPUs or to large memory systems, and where the available shared area, it just isn't sufficient for their needs. This is the third generation of Blue Bear. This part of Blue Bear, as we've actually been going, has which is a sort of a follow-on from version 2, started in 2012. And what we do is we do rolling updates of both the hardware and the software side of things. So we say it's the same Blue Bear, but now actually we've got no original components from the 2012 iteration of it. But in some way, some of the components we've got now overlapped with some of the components we had there. And we've replaced we've now gone through 2 different storage systems that have become end of life and been decommissioned, and so on. What do we have available in our system? We don't have separate, because of that, we don't have separate clusters. So we have one login system, and from that you can access a bunch of different types of CPUs, some with GPUs, submit jobs out. At the moment, we're running a mix of CentOS 7, well, mainly CentOS 7. We have Red Hat on the IBM Power 9 nodes. The Sandy Bridge I've crossed out there, that was what we decommissioned last year. They'd become end of life, so we decommissioned the last of those about Easter last year. At the moment, most of our Intel-based GPUs are attached to either Haswell or Broadwell CPUs, or in fact all of them. So Cascade Lake, we actually have 2 generations of Cascade Lake where the difference is in the type of interconnect. ConnectX 5 versus ConnectX 6, I think that's correct. Networking is always a little bit of somebody else takes care of that and tells me what we've got. We also provide a cloud infrastructure, which is effectively where we allow the researchers access to a equivalent of a compute node, but as a virtual machine instead. And these run a combination of either CentOS 7 or Ubuntu 16. They tend to have NFS and no InfiniBand connections on them. What does our software stack, or what sort of going to go with what we installed last year? We did over 1,000 installs last year, and we did over 1,000 the year before. The image there has it was generated by one of my colleagues. I'm just quickly reading his notes. The word cloud shows all the applications we built with the font size proportional to the number of modules for a given application name. The OSU micro benchmarks and HPL are quite big because I spent a decent chunk of last year trying to work out debug some problems both with MPI and with our compute nodes, and installed them on every single tool chain we had. You can also see some of the things like Rely On and TensorFlow that are some of our bigger users or bigger use cases. I've also split out there where our installations are in terms of the EasyBuild toolchains. So you can see we're mainly using the FOSS and FOSS-CUDA area toolchains. When I've put FOSS and FOSS-CUDA there, that includes any of the things. So FOSS includes the GCC toolchain and the GOMPI toolchain, those sub-toolchains, and similarly for anything else. I've also put toolchain generation for the EasyBuild toolchain generation for there. You'll see that, you know, well over half of our installations were against the 2019B. And again, when I say 2019B there, I also mean whatever the underlying GCC core version was there. I think it's 8.3. We did end up doing more installations against 2020A than I was expecting. Due to CUDA and some other issues, we were looking at jumping to 2020B and ignoring 2020A, but about September, I think it was, somebody asked us for our version 4, which in the EasyBuild was in 2020A. So that, I think, accounts for most of those 254 by itself, particularly when I think the other thing was asked for was a TensorFlow version against it. The TensorFlow version in that tool chain as well. So EasyBuild at the University of Birmingham. We've been going since 2016 with EasyBuild, which is about a year and a half before I joined the team. In fact, none of the current people building software was there when we started with EasyBuild. We've inherited it and changed it since then. All of our installations are by request, so we don't preemptively install anything anymore. We just wait for our users to ask for it. We get quite enough installation requests in that method. In conjunction with talking with the user, we decide what tool chain we're going to install it against. That allows us to sort of manage where we're installing and not installing in too many different areas. And for sort of our own sanity, we tend to have only 2 active toolchain generations for installations at any one time. So currently, we'd only be installing in the 2020A and 2019B toolchains. That's there. I mentioned that we had the different CPU types. If you're on an Intel system and you module load something, it will load a version that's been optimized for that CPU type. That's transparent to the users. They don't know what's going on. They don't see what's going on. It just happens. We set the module paths correctly. We have a few users that self-build their software that's outside of EasyBuild, using the obviously modules from EasyBuild, and where they're looking at running on the different CPU types, we talk them through how to correctly set that up so that when they're installing, they're all building their own software across different CPU types, they'll end up with an optimized version for each CPU. And we find that to be quite successful, and the users there understand there. Talk about a few of the things we looked at doing last year. One of the major things was we were looking at doing an OS upgrade where we'd take the CentOS 7, go to 8, or Red Hat at 7 to 8. We did all the installation work for that, or nearly all the installation work. We decided we were going to use toolchain 2018B for the x86 systems, 2019A and newer for the Power 9 systems. We got all this work done, and about a week before we were going to do, CentOS turned around and went and made that announcement that I think you'd probably all be aware of. We haven't quite decided what we're going to do yet. We decided we'd go ahead with the upgrade of the GPU nodes and Power 9. This is because most of our GPUs are actually on the Power 9. That's Red Hat, so we have support. So didn't seem any reason to avoid that upgrade. Our CPU-only nodes are currently still on CentOS 7. We haven't yet decided. I've put some of the options we could go with there. There are plenty of others, I think, as well. We will make a decision at some point. That's one of our jobs for some time this year. The next bit, MPI. This is one of those areas that caused me a bit of annoyance last year. And I spent a while trying to debug Intel MPI issues. I've referenced there two bug reports that are in the EasyConfigs repository, numbers there. I think we definitely experienced the first one. I think that it was the second one we experienced, or at least something very similar to it. Partway towards the end of the year and then at the beginning of this year, I went 2% of our software uses Intel MPI, or 2% of our installs last year uses Intel MPI. I've had enough of this. We're going to go IOMCL instead, i.e. swapping out the Intel MPI for OpenMPI for those tool chains. And that's working, but basically that's because we already know how OpenMPI works on our cluster, so we'll just use it everywhere. That seems to be going quite well and is there. One of the things to note about that is most of the software we install with the Intel compilers and MKL are standalone bits of software where the users just use that one bit of software with not a lot of dependencies are there. Things like Quantum Express or NWChem are in that. So, they benefit from the Intel compilers and MKL, or they tend to from what we've seen, but going out to OpenMPI is fine. Last year, obviously, we switched to having a lot of people working from home, obvious reasons. So we deployed and opened up an Open On Demand instance, which is a HPC portal to the infrastructure that we've got there, to the compute nodes. We provide through that's from the Ohio Supercomputing Center. We're providing a bunch of GUI apps from that, ANSYS, Abacus, MATLAB, ParaView. I think there's some more that I've forgotten there. Also things like Jupyter Lab, RStudio Server, VS Code. It also provides shell access through so you can get into a bash shell on a compute node through a web browser, and also a file browser. We're finding that very useful. There are alternatives to that, and I know some have been mentioned already this week. We're very much enjoying that. And the last chunk is I mentioned we were a tier 3 site. Well, actually, our big news of last year was the announcement of Baskerville, which we are becoming a national tier 2 accelerated compute facility. That's us in conjunction with the Diamond Light Source, Rosalind Franklin Institute, Alan Turing Institute, and EPSRC. We'll be providing a tier 2 system with GPUs. I'll explain what we're putting in a minute. Our technology partners are NVIDIA, Lenovo, with OCF as our deployment partner. This is again going into our data center. We're putting in compute nodes, 46 1U systems. One half of the 1U system is 2 Intel Xeon processors, 512 RAM, and SSD. The other half of the 1U system is then 4 NVIDIA A140 GPUs. Apparently each of these has about 53.4 teraflops per node. And I forgot to copy in that from memory, that's the the GPU part, and the CPUs have a bit more on top of that, but I've forgotten to put down what they're rated at on here. We're also 5 petabytes of storage going in spinning disks, about half a petabyte in flash. And one of the things we put in last year in Blue Bear, we enabled a Globus endpoint, which we're finding very good for data transfers. And that was a precursor for the tier 2. Test it on our own system first, because to see whether it will help to provide to our partners. And at that point, yeah, I thank you for listening. And are there any questions?
Okay, thank you very much, Simon. Are there any questions for Simon, either in Slack or in Zoom? Yes, we have Jörg. Go ahead, Jörg.
Yes, me again. Throwing in that question, we all know about the CentOS problem, put it like that. And you mentioned SUSE, you mentioned a few other distros. What I haven't seen is something like Ubuntu or Debian. Do people actually consider that?
But we probably would go down the CentOS, well, you know, sorry, some sort of Red Hat based distribution or SUSE. There are some questions about some of the applications we have to support as to whether they're supported on Ubuntu. I'm particularly thinking Abacus Ansys, that's a decent chunk of our users. And I think at least one of those isn't supported or is only supporting limited versions. I can't remember exactly. I know we've had some problems setting it up on there. We might, but I would think our sysadmins are more knowledgeable about Red Hat and prefer it. So we're likely to go something in that line. I don't know though, we're still discussing. We need to test it, I think is the answer.
Yeah, I think that is really what we need to do. We need to test it on a Debian-based system like Ubuntu or Debian to really see, can we switch over, or are we really stuck in the Red Hat, i.e. RPM-based world? I don't have an answer to that as well.
There definitely are EasyBuild sites who are using Ubuntu. I think Oka can maybe say something about that. Yeah.
A big pain in the ass.
we only heard pain in the ass. We didn't hear the part before.
Abacus. Apart from that, I haven't seen any problems with almost anything.
Yes, unfortunately, that's a big pain for us.
I have patches.
Yes. Yeah, it's difficult is the answer. You know, I think one of the things we might discuss is whether it's more work or harder work to split out in some way, whether we might have bits on different OSs, because we're already to some extent supporting different things, or, you know, deploying through some sort of container or something sitting on top. There are options, but we haven't explored them yet.
Just a small comment from the EasyBuild side. If you're looking at SUSE as well, that's definitely a way less popular OS than anything Red Hat based or anything Debian based in the EasyBuild community. And we are aware of some issues there, which I think are small issues and let's say rather obscure problems that are probably easy to fix. But you may hit more, especially if you're installing lots of applications. If you're one of the only sites really using SLES or SUSE to a big extent, then yeah, you may. I mean, you're already sort of in a corner, and that maybe brings me to the power aspect. You didn't say a lot about how much of a pain it is to support a power system, and you've definitely contributed back a lot of that stuff to EasyBuild.
So we've changed focus a little bit with our power, in that, having tried lots of applications, we now have a very good understanding of what is likely to work and which users we're targeting to use on it and what software we're going to use. So we've tended to focus down the traditional AI, so TensorFlow, PyTorch. GROMACS is heavily used, and a couple of others. Yes, it's. I think I personally wouldn't head towards IBM if I wanted to run everything. I would want to be focusing certain subset of applications compared to what, I mean, I talked about us having 1,000 installs last year. Most of those, there's probably a couple of hundred of those on Power. And a lot of that support library. One of the things with going to Red Hat 8, there is for CUDA versions 10 and below, there is a glibc issue. There is a bug report on EasyBuild with it, which includes some of the links to the patches that have then been applied to some of the bits of software. But yeah, seemingly anytime we change something, we hit another problem.
So the Power 9 cluster you have, you say you run some of the bigger applications there, and you try to offload those to the Power system and free up the other system for the bioinformatics and God knows what stuff?
Yeah,
or?
Well, yes. So in terms of, that's where our most of our GPUs are. So if somebody's coming to us going, I want to run TensorFlow, I want to run PyTorch, I want to run GROMACS, whenever anybody asks us a question, even if they're asking us a completely different question, we'll go, well, do you know about our Power 9 nodes? Go and use those instead, or go and use those as well. Because that's what we're finding is very good on them.
Okay, sounds good. I don't see any other questions, and we're getting close to the next talk, so let's wrap up here. Thank you very much, Simon.